Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Neila Putri Shofiyana. I am student of Said Ali Rahmatullah State Islamic University, Tulungagung. In this video, I will show you all about my experiment under the title The Effect of Visible Light and Substrate Variation on the Germination of IWSC. The early growth of ZMS is strongly influenced by environmental factors, particularly light intensity and substrate type. In a study by Wang et al. 2023, visible light was shown to trigger photosynthesis and activate growth hormones, which are crucial during the germination and shoot elongation phases. On the other hand, substrates such as soil and moist cotton serve as planting media that provide essential moisture and nutrients. In recent years, a coenzyme derived from the fermentation of molasses and sugarcane bagasse have gained recognition as cross-protein agents. According to a study in Onward 2024, a coenzyme enhances microbial activity and nutrient retention, contributing to more optimal root formation and shoot development. This experiment utilizes two lighting conditions, light and dark, and two substrate variation, soil and moist cotton with water and a coenzyme solution. Its aim is to evaluate the synergistic effects between visible light and substrate on the early growth dynamics of GMS. The experiment was conducted for 5 days with two types of substrate, namely soil and moist cotton mixed with a coenzyme and water. Its substrate was tested under two lighting conditions, light and dark. The observed parameters include germination rate, root length, and early seeding morphology. What steps need to be taken? Let's see. The following is the process of making the substrate from soil. First, prepare the tools and materials, namely water, a soft soil, corn seed, and a small plastic bowl. Second, put the soil into the plastic bowl. Next, make holes in the soil and insert corn seed into the holes, water the soil, and label it with the description, dark soil and light soil, along with the date of preparation. After that, place it in the dark and light location. Observe it every day. In the afternoon, take photos and record the development. The process of making the substrate from moist cotton includes the following steps. First, prepare the tools and materials, namely cotton, corn seed, a coenzyme, water, a 50 ml beaker glass, a 500 ml beaker glass, and a pipette. Second, pour 33 ml of water and mix it with 1 ml of a coenzyme. Then, homogenize. Third, put the cotton into the 500 ml beaker glass and drop the coenzyme mixture onto it until evenly distributed. Next, place 3 corn seeds on top of the moistened cotton. Finally, place 1 beaker glass in a light location and the other in a dark location, and observe every day. In the afternoon, take photos and record the development. What's next? What will happen to those corn seeds? Let's check. On day 1, corn seed in the soil substrate showed a visible sign of growth. By day 3, a clearly different emerged. In the dark condition, the shoot elongated rapidly, but the leaf primordia had not yet appeared. Meanwhile, in the light condition, shoot growth was slower, but the leaf primordia began to emerge. In the moist cotton substrate with ecoenzyme solution, there once saw the initial setup with no visible growth. By day 5, growth became evident. In the dark condition, shoot emerged more quickly and roots elongated significantly, with leaf primordia beginning to form. In contrast, under the light condition, shoot and root growth were slower and leaf primordia only began to appear. The following table summarizes the early growth comparison of GMS based on substrate type and lighting condition. In soil substrate, dark condition led to faster shoot elongation, while leaf primordia only began to appear on the tree. In contrast, under light condition, shoot growth was slower, while leaf primordia emerged earlier. In moist cotton substrate with ecoenzyme solution, darkness promoted faster shoot and root emergence, with leaf primordia appearing on day 4. However, under light condition, both shoot and root growth slowed, and leaf primordia only appeared on day 5. This finding aligned with Shofiyana et al. 2024, who found that ecoenzyme application increased plant height and leaf count in corn during the 3rd and 4th weeks after planting, especially in low fertility soils. Azra et al. 2021 also reported the banana peel-based ecoenzyme accelerated root and stem growth in locally glutinous corn, particularly when combined with organic substrate. Pepper et al. 2024
emphasis that highlight intensity enhance photosynthetic efficiency, though it does not always correlate with shoot elongation. This experiment shows that light and substrate type significantly affect the early growth of DMS. Soil in dry conditions led to rapid shoot elongation, while light accelerated the emergence of leaf primordia. In moist cotton with ecoenzyme, darkness promoted root and shoot growth, while light slowed it down. This ecoenzyme helps perform to support growth by enhancing microbial activity and nutrient retention.
Thank you for your attention. I hope this experiment not only expand our understanding of plant growth, but also inspire a small step toward more sustainable, science-driven agriculture. Let's grow knowledge, one seed of insight at a time. Wassalamualaikum warahmatullahi wabarakatuh.